Hi there, Andrew Jackson, AJ Design Studio. Another video sort of continuing with my recent series of blends and transitions, different videos covering different ways of doing things. Had a question from someone online about doing maybe combining a bunch of techniques together into something. So I've dusted off this old, it's a mountain bike Headtube and Toptube and Downtube exercise that I've sort of been dabbling with now and then for a few months and never actually sat down and tried to flesh it out properly. So I've got a series of models here that of sort of my processes I went through to achieve this result here. So if you people that aren't really in the ride mountain bikes or anything like that, so basically the new standard most mountain bikes have is a tapered head tube. So 1/1/8 I think on the top, and the 1/4, 1/2, I can't remember, on the bottom. So you've got this sort of tapering, sort of hourglass shape going on at the front, and then your top tube and your bottom tube, and blending everything in nicely together. So as you can see, yeah, so I'll just roll through a few files here and just show some things I tried doing, things that didn't work. There you can see the patch layout. Right, so I'll just roll up to the top here and cover a few things. So I created a revolved surface, which is my sort of main surface for the headset, for the head tube. So create planes at the top and bottom, and then I have created my main layout, so centerline layout. So a bit of taper on the down tube, taper on the top tube. Just a sort of a guide for the blend here. And then I've started creating my hourglass sort of form for the head tube. So this revolved surface here is just a guide, so I'm going to hide that. So for my hourglass, if you have a look at several mountain bikes, they have this kind of hourglass thing going on rather than just a straight transition. So this is no particular bike, and in particular, it's it could be a cross between a Santa Cruz and something else. It has a similar sort of look. Okay, and because at the top I'm not just going to use a cylinder and then try and blend in with a tangent, I want to try and make a curvature continuous join. What I've done is I've gone in, and if you've watched any of my other videos, we have an arc, and then I'm blending that arc to a line here by using a style spline. And that style spline, if I select it, it's a degree 4, so it's got 5 CVs. So curvature continuous to the arc. So I've got 1, 2, those points taken up with the curvature continuity on this end. And then these control polygon segments are collinear with my straight line, so they're horizontal. And then I've done the same thing at the bottom. You can see I'm going to create a surface between those two. So there's my planar surface that I want to create a blend here, so we can go curvature continuous. The curvature you can see with the graphs there, the curvature is dropping to 0 where it hits the planar face, and then it's this section here forward of the graph is an arc. Okay, so I've just created that with a loft. So the loft on one end, we've got this hourglass thing going on in the front, and then this end I've got my planar face, and then as you can see the curvature is coming around as an arc and then dropping to 0. Well, it's an approximately as an arc because I've got an hourglass form here. So right, I better speed up. Okay, now I'm just going to extrude some surfaces. So top tube, bottom tube, main faces, which are just crowned. Okay. So this first version, I had grand plans of making these surfaces here and creating the blends and then patching everything in. But it turned out to be a bit of a grand failure doing it this way, because I've got to transition from here through to two branches, you know, and it's all over the show. I haven't actually intersected my primary surfaces first before I started trying to get this blend going on. So I figured this was not the best way to do it. So that's where I moved on to version 2, which you can see is quite different. So what I've done is I've decided to create a larger overbuilt surface, then gets trimmed back, and I'll just go through this. So I've created a plane at a point. This is an offset from the front plane, and then if I go into the sketch here, I've got an arc for the crowning on the down tube, an arc for the crowning on the top tube, and then I've joined them together with a degree 5 style spline, curvature continuous on each end to the arc, and then created some side profiles to blend, because what's going on here, I'll show you. So this is the arc. If this was a true revolve right round, so there's this section of arc segment there, and then I've got a curvature continuous blend running it out to so I can run straight back from this point, because if I just chop the arc here, I'm going to end up with a tangent connection. So from this surface, which is the loft I created earlier, got a 3D sketch with a style spline on it, degree 5, 6 CVs, curvature continuous at this end, and by making it curvature continuous, I haven't actually used the curvature continuous constraint, because the curvature drops to 0 on this surface. I'm also doing the same here, so these control polygon segments are collinear with the control polygon segments on the spline here, so that's straight, it's all straight. And the same thing happens here. The side of the down tube is linear, so these two control polygon segments are collinear with the side here, which gives us a control curvature continuous constraint. Okay, and I've done the same thing up the top, as you can see. And then yeah, I just made a boundary blend. So, whoopsie. So that appears to be, trying to read the zebra stripe there, appears to be curvature continuous to the head tube surface. So the idea would be then to trim out this section here. Right, I'm going to go on to the next file now. So what I learnt was I don't want to have that surface as in the previous file. It was vertical here. I want to get a bit of angle here, so we're not such an acute angle to the down tube. So I've redefined things down the bottom of this tree, but it's pretty much the same. This end section still has crowning on it. So after I did that, I'm going to put in the side surfaces of the down tube and the top tube. So because this surface here is undulating, the bottom edge of the down tube isn't going to be linear. The top edge is linear, so this curve here, I have to define a spline through here, which is curvature continuous to a 3D sketch here, which is an intersection of this face and this face. That's curvature continuous. I've projected that down onto a plane, and then on this end it's coincident to the point on the top, because I want the top tube to be the same width by this point. Okay, and I've done the same thing on the bottom, and then I've used that to trim that surface back. I've done the same thing on the bottom. Then I've just created a crown face here, so it's got an arc on this end. And if you remember this surface here, that's got a crowning of 100 as well. It's on an angle, so it's probably not 100 exactly, but okay, now I'm doing the same thing on the bottom. I've got to create an intersection between this face and this face, and then create the curve. Oh, and as you can see, this was the problem with this one. This one bellies out because this surface is too far forward at this point. So that's why my trim curve here, it's bellying out, which is not a thing we want. So I'll go into my next file where I've updated things and got around that problem by controlling the surface and dropping this backwards. Okay, number 4. So in the previous file, that surface was bellying out. I'll just turn edges on because my big overbuilt surface here was too far forward at this point. So I redefined the sketch controlling that, so I can control the dimension here and here. So there I've got my crowning, but it's not equidistant from the center plane. So you can see the whole thing sort of drop down more, and then that has allowed this and this face to not sort of belly out. I really must specify my recovery directory. Okay, what else have I done here? I've got my overbuilt surface, and I have created a blend for the center line, and then from the endpoints of that blend I've created some planes, as you can see, and then started trimming back the inner faces of the down tube and the top tube. And then I've created a sketch which is the outside trim, which trims back my overbuilt surface to create this elbow, and then I've created a loft in there. I tried various surfaces. This loft seemed to be the best, so if I bring up my zebra stripe, so okay, let's move on. What we got now? Okay, started looking at the top here, trimming back this overbuilt surface, and again, what I did with the hourglass surface on the front, how it has a segment of an arc and then it transitions into a spline to go to zero curvature. I've had to do the same thing because my arc doesn't actually, there's the arc, so my surface is inboard of the arc. So what I've had to do is create this curve here to finish off connect the surface edge to the center line. To connect here to the center line, I've used this piece of an arc here, and then this curvature graph here. You can see there is another style spline there. So you can see I'm a slight bit off being on the arc, but I don't think anybody's going to notice. This is going to have a fillet over it, and then it's going to have a headset cup over the top. Okay, so for this version here, I tried running this in this blend in one go, but this is a four-sided boundary surface, and obviously having such an acute and pulled edge here isn't really best modeling practice. So I tried doing it as a surface fill, which worked okay, but then I'm trying to avoid using surface fills. So my next step is doing this out of four-sided boundary surfaces, but breaking it into two surfaces. So I thought, okay, I'll build one boundary surface here where everything is fairly even. You know, there's no drastic acute angles on the corners. And then the idea was how I'm actually going to get this triangular patch built. Which takes me on to the next file. Okay, so what I've done is I just roll back. So there's my four-sided surface from the previous model. Then what I've done is created a plane through the end of this spline where it finishes here. So I've decided, instead of explicitly trimming this back and having a surface there, I'm going to build a four-sided surface that projects through these two faces, and the trim will be resultant. So that way I get a four-sided surface that isn't pinched or collapsed down to a singularity. So I've created a plane through the end point of this spline here, and then I've created a piece of floating geometry, so a spline that I can tweak to try and tweak the shape of this four-sided surface I'm making, overbuilt four-sided surface. And then I've created the outside boundary, so you can sort of see where I'm going here. I'm going to create a surface with these four boundaries in here. So there's that. And I have tweaked angles and what have you, sort of tweak the resultant trim. Okay, and then I just trim everything with each other to end up with this curve here. And because this is an overbuilt surface, it's not nasty having it come down to a point like this, because the actual untrimmed surface is rectangular with no acute angles. Okay. Now I'll jump through to my last file, which covers the bottom. Oh no, it's my second to last, sorry. Okay, so the bottom was pretty much a similar type of construction. I've created this curve here, which is way up the top in my side elevation control. Created a plane through there, the end of that spline, which is used to trim back the underside surface of the downtube. And then I've done what I had to do on the top here. I've done the same thing here on this in this sketch here. So I've got a piece of the arc, which I've set back from the front plane, which is the axis of rotation, is the front and right. And then I've created the style spline, so I'm curvature continuous to this piece of arc and this piece of arc. And then I've swept this profile, the crown profile from the underside up along this style spline here. Sum of curvature, it's all equal. So it's 50 millimeter radius. Then I've extended this surface out and trimmed it. So now I need to create this blend here. And again, I'm going to use the sort of resultant technique that I did here so I can end up using four-sided patches. Four-sided surfaces, sorry. Oh, hang on. Yeah, this is my first attempt where I tried in the old surface fill there. So that's probably sufficient. But I'm going to add radiuses to the edges here, and I prefer not to use a fill surface. I mean, that's not too bad. You can see it's a tangent connection there because there's a kink. Okay, so I'll go into my last file here. So version 8, just roll back before these fillets and show you how I built this pretty much the same as I did the top. Four-sided surface there. Sketch on this end here. I have to make it tangent to the surface, so what I've done is extended the surface out, as you can see, and I've created a plane 19, which is perpendicular to this arc segment and coincident to a intersection here between the surface and the surface. Created a sketch with an intersections curve through this face to make it curvature continuous there, and trimmed, added this loft, and much like the top, created some geometry hanging in space because I want to create it. Hang on, where are we? I want to create a four-sided surface through here. So there you go. You can see my boundaries: 1, 2, 3, 4, and there's my surface. So now we're just going to trim things back. You can see the resultant junction, which I've tweaked a bit by tweaking these sketches. So series of trims like that. Hey presto. Okay, now I'm just going to cap things up with some planar faces. So I've capped the ends and knitted everything together. Now I'm adding the radii, the fillets on the outside. So this is curvature continuous fillet, radius 4. Same on the top. Same on the center. For here I was going to sweep a pipe around here and then rebuild the surfaces in to get a nice equal distance blend off the rail, but if you use base fillet, you have the option of using chord width as the input. So if you go symmetric, you end up with this wobbly stuff going on, which is what I mean why you'd sweep a pipe along here, because if you sweep a pipe you get an equal distance off the edge. But luckily, face fillet, you have the option to pick chord width, so it's sort of much more even. It's not perfect. It's not as good as doing a sweeping a pipe along there, but yeah. And same on the bottom. And then I've just mirrored surface over, thickened it, and cut the head tube out. Okay, so this is the result. We'll just have a look at it with the edges off. So I think all in all it's pretty good. You can look along the top of the down tube there and you can see it running into the blend there, into the taper, and then around the top. and along the top there. Looks fairly smooth. Yeah, so there you go. There's a more involved transitions and blends video using something, you know, like a real life application of multiple techniques and showing some failings. So yeah, using an overbuilt surface for this area was the way to go. I think if I had tried to build this out of lots of little patches, like if I had built these surfaces first and then tried to make this out of patches, it would have been a nightmare. So yeah, I think that's something I'm starting to do more and more with my work, is if you can build it with an overbuilt surface rather than doing lots of patchwork quilt stuff, much better. Anyway, if you find this video useful, please subscribe to my channel. It sort of motivates me to do more. I hope you find this useful. Thanks for watching. Andrew Jackson, AJ Design Studio. Bye now.